Hello physics students. Welcome to the Law of Reflection Lab. Now at this point, you should have already printed out page 2 of the document in the Google Classroom stream. This is where you're going to generate all your data, record it, and analyze it. Page 1 is just instructions, so you don't need to print that out. Now the purpose of this lab is to verify the law of reflection. But we already know the law of reflection. It's right on our reference table in the waves section, right here where my index finger is. You can see the equation theta incident equals theta reflected. So we're going to test that by what we're going to do is we're going to create a bunch of light rays coming at a mirror, and we're going to allow them to reflect and note the reflected ray. We're going to measure theta incident for all the incident rays and theta reflected for all the resultant reflected rays. We're going to create a table, and then we're going to graph those two and see the pattern that emerges on the graph. From that, we'll be able to tell if the law of reflection holds. So let's begin. Come closer. I'll guide you through the data collection and the data analysis. So here's the lab sheet. I zoomed in so you can't see the whole thing, but you could see the table here, the graph. What I'm going to do is bring the paper up so you could see where we're going to be creating our data. So right here, what I'm going to do, actually maybe I'll practice, is I have a mirror on a little block here that holds the mirror up, and I'm going to put this mirror as close to I can to the, so that it lines up as perfectly as possible with the line on the lab sheet. So somewhere around there. Okay. So the mirror is lined up with that sheet, this line 1 on the lab sheet. Now let me slide this, hopefully I don't move the mirror up to the top so it's at the top of the screen. What I'm going to do is take this light box again, and I'm going to turn it on, and you can see the ray reflect off the mirror, and I could create a bunch of reflected rays by moving this box around. The first ray that I'm going to create, I'm going to make it pass over this point marked X, and I'm going to try and have it hit the mirror at the point labeled A. So you see that's pretty good right there. And then what I'm going to do is make a note of where that ray reflects by putting a dot right here on line 2, and I'm going to label that because it came from point A. I'm going to label it A prime. Next, what I'm going to do is I'm going to turn this ray so that it still passes over X, but this time hits the mirror at point B. So let me do that there. Okay, that looks pretty good. And then I'm going to mark where the reflected ray passes line 2, putting a dot here, B prime. And then what I'm going to do is continue on for all the points, but I'm always going to make the ray pass over point X. So something like this. And now this ray crosses line 2, as you can see right here. I will label that, since it hit C, I'll label this C prime. Let me do D now. And you see the pattern is I'm increasing the angle of incidence, the angle reflected also increases. Of course, that's because they're equal. I'm going to put D prime right there. Let's go to E. And I'll put a dot right here. E prime. F. And a dot right here for F prime. And then I'll continue to G. And this will be now G prime. And then finally point H. I hit the mirror at H, right there. and it reflects right here, so I will label this H prime. All right, so I found all my points. I could put the light box away, I don't need it anymore, and I could move the mirror finally. Now the tricky thing is, how do I get you these points at home? How could I tell you where they are? So what I'm going to do, now of course if you were in class you would make these dots like this for the experiment. What I'm going to do is I'm going to measure these in centimeters. And I'm going to create a bunch of measurements. Like for example, this is at 2.15 centimeters. This one is at 4.40 centimeters. C prime away from X measuring is about 6.42 centimeters. D prime is about 8.5. Well, I don't need to measure all of these now, but you see how I measured them. I measured how far away each of the points was from X. So what I'm going to do is I'm going to give you in the Google Stream a bunch of numbers for how far away to mark your points so that everyone gets their own data. So when you see those values in the Google Stream, go ahead and just take a ruler, set it down like this, and put the dots for each of the points. Put the ruler down one time, line it up with X, and then just put all your dots for all your points. And then once you put all the dots, boom, 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 based on the centimeters given you, move the ruler and label A prime, B prime, C prime, D prime, E prime, all the way to H prime. So go ahead, open the document of the data in the Google Stream, and measure out where these points belong. Go ahead and do that now. Okay, so now what we have to do, remember, there were actual rays that produced these. Like if I put this here, right, then this was a set of rays that went from X to A prime. Another set of rays went from X to B prime, X to C prime. These were all rays that what we're going to do now is trace the rays. Of course, when I shut out the light, they disappear. But what we're going to do is take a ruler and trace all the incident and reflected rays. So let me shut off the light, move the mirror, and show you how you're going to do that. So you take your ruler and you connect it to X to A, like this. And then you draw a nice, careful line. Now, you're not drawing the line to the letter A. You're drawing it to the place where this line, which actually represents the normal, where it crosses line 1. So right here, hopefully you could see that on the video, but all the way to line 1, that's the impact point that ray 1 came in at. Okay? And then it reflected off of A and went to A prime. So what I'm going to do is go like this. Now, what I want to do is I want to measure these two angles and see if they're equal. They should be, but of course, in an experiment, it doesn't always turn out the case that you get what you expected. All right, now, so I have to carefully align the protractor here. Let me make a crisper line like that. As usual, the tripod's in the way, makes this difficult. Maybe something like that. So what I do is I calculate what the incident angle is. And the way I do that is I start, how's that lighting? I start at the normal and I count over this way. Here's 5 degrees, 6, 7, 8.4 degrees is what I get. Of course, you're going to get something else because I'm going to assign everyone different data. And then this angle here, the reflected ray, I'm going to measure what that is. Now, it should be 8.4, but don't just write 8.4. This is an experiment. You're measuring what it actually is. And it may not be 8.4. Here's 5, 6, 7, 8 exactly. So the reflected ray is 8.0. So when you're graded, you won't be graded that these two angles are the same like they're supposed to be. You're going to be graded that you measured them accurately. So you see in my table here, what I did is I recorded those values, 8.4 incident, 8.0 reflected. So go ahead and construct your rays, as I did, and then measure the incident and reflected angles. Go ahead and do that now. All right, the next set of rays was, well, one began, the ray began at X and went to the mirror at B. So same thing, don't draw it to the letter B, draw it to this line which represents the mirror, like this. And then it reflected from B and went over to B prime. So I will draw that in now. All right, so go ahead and draw in this incident ray, this reflected ray. Go ahead and do that now. Okay, so now we have to measure the incident and reflected angles. So again, I will line up the protractor as best as I can. Something doesn't seem right. Either my protractor is off or the paper is, the printer didn't print out these lines perfectly, but we'll do our best. So I'm going to measure the incident ray. Remember, this is the incident ray. It came in, and I count the angle 10 degrees here, and it looks like it comes in at 15 degrees. Yours will be different. And then I'll measure this one, 10 degrees here, and it looks about 14 degrees. So 15 degrees and 14 degrees, what I'll do is I will write 15 degrees and 14 degrees. And by the way, I don't need the degree symbol because it's already in the table here. So go ahead and measure your two angles and record them now. Okay, next, what we need is to construct the ray that's coming in and hitting point C. So what I'm going to do is start at X, remember that's how the light went, and impacted the mirror at this label C. But again, you're drawing it to the mirror, not to the letter C. It reflected off the mirror and went over to C prime. There. So go ahead and construct the incident and reflected ray to C and C prime. So go ahead and do that now. Okay, so next thing, I need to measure the incident angle and the reflected angle. So I'll get my protractor, line it up here, like that maybe. It's hard, again, the tripod's in the way. Maybe you can see from above that it's not the greatest alignment, but we do our best. So the incident ray is this one right here. So right here, I'm going to count over. Here's 10, 20, a little less than 21. I'll say 20.9. And then the reflected ray is right here. So I'm going to count over 10, 20, well, a little less, 20.8. So I transferred those into the data table right here. So go ahead and measure your angles now. Okay, so continuing on. Now I need the ray that went from X to D. I will construct that on the paper, like so. Okay, hit at D and reflect it to D prime. So something like this. So go ahead and construct these rays now. All right, so I need to determine the incident angle and the reflected angle. So let me use my protractor. Okay. And I count over, this is the incident ray right here. 10, 20, 5, 26 and a half. The reflected ray is right here. 10, 20, 5. This one's 26 and a half. This time they came out the same. So, okay, so go ahead. I copied them here. Go ahead, copy them now. Again, I should have said this earlier. I mentioned it, but again, I want to emphasize. Don't just make these all the same. Then you're just making up data. You have to measure, and they may not be the same. If they're the same, that's fine. If they're not the same, that's fine. All that matters is that when I get a protractor out and measure the angles, these numbers are accurate for your data. So go ahead and make your measurements now. Okay. Next, the ray to E. This is where it came from. It came from X, hit the mirror at E, bounced off and went to E prime. So let me construct the reflected ray. So go ahead and construct those rays now. All right, so what I have to do is measure the incident angle, the reflected angle. So let me align my protractor. Right. A little too far. All right, so what I'm going to do is count over to the incident ray right here. So that's 10, 20, 30, 31.0 degrees. The reflected is 10, 20, 32.5. All right, so I put my measurements in my data table. You go ahead, make your measurements, and write them in the table now. All right, 3 more to go. So the next ray started at X and went to F. And then from there, it reflected to F prime. So go ahead and construct your 2 rays, incident and reflected, now. Go ahead and do that now. All right, time to measure the incident and reflected angles. Yeah, I think the normals are off on the lab sheet, so let's see, it doesn't come out quite right. Anyway, here's the incident angle, or the incident ray. So I count over 10, 20, 30, 6.1, 36.1, and then the reflected ray is 10, 20, 30, 6.8, 36.8. So go ahead and measure your incident and reflected angles. Go ahead and do that now. All right, next. The next ray we had began at X and went to G. Reflected from G and went to G prime. All right. So go ahead and construct your incident and reflected rays now. All right, we need to measure the incident angle and the reflected angle. So I'm going to align my protractor. And the incident ray is right here. Again, my normal's off, but I'm going to start here, which is the normal, 10, 20, 30, 39.8 maybe. And then the reflected ray, 10, 20, 30, 40, 1.0. So go ahead and measure your incident and reflected rays and write your data in your data table now. One more. So we had a ray starting at X and going to H. And then reflecting off of H and going to H prime. So go ahead and construct your incident and reflected ray now. Okay, so the next thing that we have to do is measure the incident angle right here and the reflected angle. So let me... Okay, again, this normal's off also. Starting from the true normal here, I'm going to go over 10, 20, 30, 40, 43.5. And then the reflected ray, 10, 20, 30, 45.0. So go ahead and measure your angles and transfer them into your data table now. Okay, so that is the data of the law of reflection. Again, these should have been equal. They're probably not, or they're not going to be equal, at least not all of them. But what we're going to do now is plot the data to see how close the trend is to what we expect. So what's going to go here is theta incident. This is going to be the x-axis. This is the y-axis. So remember, you got to put a label here with units, a label here with units, and a title. So go ahead, put your labels and units and title into your graph now. Next, what we're going to do is figure out the scales of these axes. Basically, our biggest point is 45 degrees, incident and reflected angles. So figure out a scale that will nicely fit this data. Go ahead and scale your axes now. All right, the next thing that we're going to do is plot these points. So we will, 0, 0 is 1. Mine is, let's see, 8.4. So that would be somewhere, if I scaled my axes, would be somewhere around here, maybe 8.4. No, 8.4 would be somewhere around here. And then 8.0 would be right around here. So I would put my first point here. The next point, 15 and 14. So that would be somewhere around here. And 14 would be somewhere around there. So I put a data point like that. Let's see, how does the light look? Oops. I guess that helps a little bit. So essentially, your data points are going to be like this. I'm just kind of going sloppy, but yours are going to be better. And you're going to plot all your data. So go ahead and plot your data now. The next thing that we have to do is draw best fit line. So again, we've been doing this all along. Make it go through the origin, because that's definitely a point that when there's a 0 incident angle, there's a 0 reflected angle. And then draw a best fit line to the best of your ability. Remember, all the things about best fits must be true, and make it go the whole length of the graph. So go ahead and draw your best fit line now. All right, the next thing that we're going to do is calculate the slope of our best fit line. So let me see how the alignment is here. Okay, that looks good. So what we're going to do is, as always, begin with slope equals an equation. Then what we're going to do is plug in numbers, and then we're going to have an answer here, and there may or may not be units in your calculations. you need to figure out where, if there are any units. So calculate the slope. Again, remember, you're not using any data points. I don't care how nice they look. You're ignoring data points. You're picking two new points on a line. You're also not picking points that are close together. You're picking points that are very far apart on the line, maybe even the whole line. But again, use a big gap and plug in your numbers and calculate the slope. So go ahead and do that now. Okay, so the next thing that you have to do is right here, what should the ideal slope be? An actual number. If the law of a reflection truly held, and this experiment was perfect, think about what the slope of this line would be and write that number here. You can really actually come up with a number. So go ahead and do that now. And the last thing, percent error. So percent error, let me see the alignment here. Okay, so the percent error, this is the accepted value. This is the experiment. So again, percent error equals absolute value of the accepted minus the experimental over the accepted. Absolute value times 100%. So go ahead and calculate the percent error now. All right, well, there aren't any questions. So that's it. Just make sure you have this all completed nicely. And again, no questions to answer. So that's the data and data analysis. So that was the Law of Reflection Lab. I hope you enjoyed the experiment. I hope you enjoyed the video. I'll see you in the next physics video.